Thank you so much, Barbara. That was amazing. It's really exciting and motivating to think about all of the wonderful science you just presented on. So really appreciate your time. I'm Kelsey Young. I'm going to be moderating the Q&A for this piece. Amanda posted a link to the IO website in the chat where you can enter your questions. Maybe she can post it again now that we're talking about this, and please go in there and ask your questions. I do see a few questions in here already, and actually we're going to punt those to the next Q&A session because we'll have Joel Kearns on for that, and he is prepared to answer all of them. So the three questions about Viper and Artemis 4 instruments, I promise the answers are coming from Joel in the next session. So please go in there and enter your questions. But in the meantime, Barbara, I have a couple questions for you.
Sure.
You just presented a really exciting look at a strategy based, of course, on community documents that have been built over the years. So what can the community do now to help develop this strategy moving forward?
Yeah, that's a great question. So the first thing, obviously, is think about how we can achieve some of these big bites out of our basin chronology effort with our landing site selection. So that would be a really great thing for everyone to think about. We're trying to get that in at the end of the summer or the early fall. That's still in progress. I'm sorry, I don't have a date for you. But as you're thinking about that, like I said, as you're thinking about places you'd like to go or places you'd like to see crewed missions land to really optimize this, take a step back and think why. Think what makes that a good site, what makes that good science to do. That the underpinning for those figures of merit is always our foundational science, our foundational geology. How does material move around after it's formed in, say, the SPA basin melt sheet? How does it move around? How does it get to the South Pole sites? How do we understand our remote sensing data such that we can zero in on areas where maybe there's more or less mixing of material? How can we use different geochemical signatures, for example, from orbit? I know there's a lot of work on this. I know there's a lot that the community is doing. So I think those are really good places to be focusing in. And then these handheld instruments, I think, are going to be a really great opportunity to help us use real-time information with the crew to do things on the surface during EVA. So not just like point and shoot, do I want that sample or not? I know that's the thing that comes to mind for most people, but also crew is interacting with the surface. They're the ones who can not just roll up to a rock and stand off like it's a museum piece. They can scuff the surface, they can trench, they can roll a boulder over and look at the underside of it. So what are some of the things that we want our crew to interact with the environment and understand, say, structural geology or, mixing or trenching or things like that? I think those are really good places for the community to really put some thought and effort into.
That's wonderful to hear. Thank you. Another question is, you also highlighted a couple places where you're looking forward to learning from prior missions, like Artemis 2 and Artemis 3. Can you say a little bit more about what specifically you're going to have your eye on during those missions to prepare for this type of strategy?
Sure. Well, I don't want to take anyone's thunder away. Artemis 2 is going to be looking at crewed observations of the lunar surface, and that's sharpening our pencil for how crew make observations and how we use their information, how we, the science community, use and interpret that information. That's definitely a two-way street. They are fully members of the science team, but communication is really key. So understanding what someone means when they say a word is really important. So that is something that I'm definitely looking forward to, is how do we use the information coming to the crew and how do we understand that? How do we document that for the community going forward? Those are going to be great things that come out of Artemis 2. And then for Artemis 3, because we're so constrained on the site selection process, science is part of that. Science is helping understand the science value of the sites that come to us from engineering. So it's not totally one-sided, and I don't want to give the impression that it is. But using sort of our site selection process when we go to, using the information when we go to say, well, what was that site like? What was our understanding of the site like before we went? Maybe using some of these figures of merit that we developed for basin chronology and applying them to our ultimate Artemis 3 site that we select. trying to understand what we would have expected at that site and comparing it with what we achieve during the exploration of the site and with our samples that come back. I think that's going to go a long way towards validating what our figures of merit are and how we use them to go forward.
Thanks a lot. And that actually leads me to a question for you as well. What is a science figure of merit?
What is a science figure of merit? We still are putting some thought and effort into that. We'll definitely get into that more at the landing site selection meeting, but I'll give you a couple examples to noodle on as we build up to that. For example, the amount of thorium in the lunar megalith is broadly considered to be there, derived from samples that are rich in thorium that come from specific geochemical terrains, right? For example, the thorium-rich sites in the creep terrain, as that material is comminuted and is impacted and is diffused out into the regolith, right? That material makes up a smaller and smaller proportion of the regolith at a site, and so the thorium content that we see from orbit goes down as it's mixed in, as it's diluted. All right, so that can tell you as sort of a measure of how far away from a thorium-rich terrain you are, and or how much mixing has gone on at that site. So the material has been diluted. So if you wanted to find a thorium-rich rock and you're picking a site that has a very low thorium signature, that may indicate to you that the material there is very dilute or diffuse throughout the regolith, and it's going to be harder maybe to collect enough material that you guarantee getting something that's thorium rich. So that may be a kind of figure of merit that we would think about. Geochemically, there are other signatures of the South Pole Aitken Basin. There's lots of papers about the geochemical signature of the South Pole Aitken Basin itself. How would we identify that material when we are at a site and we're trying to collect a boulder or a rake sample or just a bulk regolith sample? Another figure of merit might be how well we can understand the underlying basin structure at a site, right? So if you're at a specific site where there are multiple overlying basins or cryptomare or something like that, it may be difficult for an instrument on the surface to understand the subsurface structure as it relates to the original SPA basins. That might be something we would think about. How well can we interpret the site that we're at? How well can we understand its geologic history such that it gives context to the geologic campaign and the materials we bring home? So ultimately, a figure of merit is going to be something that's measurable, something that we can give a numeric value to, or a qualitative high, medium, low to, and that we can attach it to the site. So it would be a site one. This is a figure of merit. How much thorium does it have? Great, I can just put the number right in there. Or how well can we understand its geologic context, high, medium, low? Okay, I can put a value there. And that allows us to sort, rank, combine, so that we can make a prioritized list of candidate sites to give over to engineering to assess for engineering value.
That was both an amazing explanation and a good plug for the workshop Barbara mentioned. So looking forward to diving into those details. Maybe to let Barbara take a breath and take a sip of water or something, I'll direct the next question to Sarah. Does QuickMap have up-to-date landing zones, and would our figure of merit be constrained to those areas?
Yeah, so currently in QuickMap, the 9 landing zones, which actually Tamara is going to talk a little bit more about this afternoon, those are in there. Those are correct for Artemis 3. Those are specific to Artemis 3, and they are based on the specific constraints that we have for Artemis 3. When we move past that, we're going to open that trade space back up again. We'll have different constraints next time. So we're going to open the trade space back up again. So as we start this discussion, we're looking at sort of more of a blank sheet, and we're asking, like, where should we go? So not in QuickMap.
Right. And just to add on to what Sarah is saying, we're not asking you to find the sites. We're asking you to tell us what makes a good site. Divorced from engineering, what makes a good site, not having a big boulder in the middle. Yeah, we know that. We'll assess that separately. What makes a good science site? And then we'll be able to convolve that with other things. So knock yourself out within the 84 degrees of the South Pole. That's only our constraint, right? That's our big picture constraint. It has to be within 84 degrees south. You know, obviously we're not going to be landing on a 90-degree slope, but you don't even have to take that into account, right? We're not trying to find a spot. We're trying to find what science makes good landing sites, what scientific qualities.
Thank you both. Let's keep the figures of merit party going. Can the eventual driving figures of merit be used to prioritize payloads and investigations to be conducted on the surface?
I think eventually that could be part of the conversation. Maybe Sarah can come back on and we can talk about calls that are already out. Sarah, I think this is something for you to talk about.
Yeah, so right. So clearly we had an Artemis 4 handheld or payload call. Those proposals are in there currently in review. You'll see that in my slides in a few minutes here, right? When we put that call out, we already knew what we were thinking about here, right? And the instructions in that call were very clear about what kinds of instruments we wanted, and those are the criteria by which they will judge by. There are no secret criteria here. We were not looking for hidden things. We were looking for exactly what we asked for in the call.
Yeah, I'm wondering too, Barbara, maybe I'm reading this through a different lens, but eventually, like when you're like thinking about implementing this strategy on the surface and mission planning and stuff like that, would you potentially use figures of merit to like plan surface activities? Not necessarily in call selection, but like in actual mission planning.
Yeah, so our mission planning relies both on having internal NASA support and our competed teams. And so they're going to play together to decide what activities we want to do to accomplish all of our science goals. I think the way that I'm thinking about something like this is that we would use this focus area to drive our big science goals, but then the actual specifics of how things get implemented. I don't think we would use landing site figures of merit necessarily, but I think it's not a bad approach to thinking about how to hew toward our main picture goals. But that's something that would be a real team effort, and I don't want to discourage any teams from thinking bigger than this. Maybe you can accomplish some of this and also something that you hold dear to you.
Well said, thanks. That actually might lead well into another question I see here, which is where does science associated with permanently shadowed regions and exploring for water ice fit in?
I'm going to ask Jake if he's still on to maybe come back on.
Yeah, I'm still here. Kelsey, can you just say the question again?
Of course. Where does science associated with permanently shadowed regions and exploring for water ice fit in here?
Yeah, so that's a great question. And in general, the Moon to Mars objectives have questions about volatiles. And if you look at the documentation we have about why we're targeting the South Polar region, it's because of access to those volatiles. So I think that is probably a prevalent thread that will wind through both anything that we can learn from Artemis 3 as much as we can once we're on the ground, and then any future opportunities we have to land in the South Polar region. That's going to be something we're trying to do. So as we look forward to the opportunities that we have, I think that will be there. If the chronology approach, if we're talking about this strategy, has potential access to places that are cold enough to preserve volatiles as ices, if they're present, then I think we probably would want to sample them. So I think that, what Barbara's presenting here is a strategy looking forward, and there's going to be multiple strategies, I think, right? Because there are many different disciplines of science that we would like to investigate at the moon in general, but in particular at the South Polar region. So those themes are going to have many overlaps, I would imagine. So when we talk about a strategy for chronology, it doesn't mean we exclude all other science and only focus on that. That might be the main approach to some future mission that we hope to conduct. But I think we're always open to the other important aspects to these other science themes. Ultimately, we get to a point where we can look at these strategies and identify landing sites that are great for more than one theme, right? And we can start trying to build together and really increase the value and return on every opportunity that we get to go and explore the South Pole, the moon in general. So although we're focusing, this point right here is a lot about the chronology and building this chronology strategy. It's not, in any way saying that we're not trying to do volatiles or we would ignore them if we identified a place where we can go do both at the same time.
Yeah, and I'll just chime in on that too. You'll see in the workshop that there is space held for other figures of merit that aren't necessarily SPAT or chronology. We know that there are lots of different figures of merit, as Jake just said. There's lots of other science that we want to do. And so those communities are absolutely welcome to participate and help us start to build those as well.
Thank you both. As I see the new questions in IO are starting to slow a little bit, I will just remind folks of what Jake said at the beginning, but in case we had folks join after Jake gave his intro. This session today is going to focus on the topics you see laid out in the agenda online. We are not going to be having detailed budget conversations here. That process, we're in the middle of handling that process, and as Jake said, that's not something that we're going to address in the Q&A sessions today, and we're really wanting to stay focused, as he said, on the content in the speakers' presentations. But if there are no more questions in IO, I actually might ask Barbara, Jake, and Sarah for any advice you have for folks preparing for this workshop that Barbara just mentioned that's coming up later this summer, anything that they can do in particular to get ready. Barbara mentioned an abstract call coming up, but anything else you guys want to speculate on in our last couple minutes?
Yeah, I'll go ahead and just say my thoughts. But, I think these, my hope is that these lunar surface science workshops, as we are in a position now to kind of announce them ahead of time, try to get the word out before the calls go out, this is a great time to reach out to your colleagues and partner, right? Like start, it doesn't have to be a whole bunch of individual abstracts. Please submit those if you want to, but great time to really, build relationships with folks across our disciplines, multiple disciplines. So reach out to your colleagues, right? Think about it. And every one of us has our own, specific interests, but, the more we can collaborate and build, not that we ever reach full consensus on anything, but the more you can kind of identify, where other groups are thinking the same way, other people are thinking about similar things, and then thinking about those overlaps. You might think about this a little bit differently than other folks, but if you can identify ways to address, multiple aspects of it, multiple facets of what makes up the strategy, I think that's really important. So now, maybe more so than any time in the past, this is a really good time to start reaching out and partnering with colleagues and introduce yourself to people maybe you haven't met yet, right? You see talks people give at other conferences. It's a great time to reach out and just start building those partnerships and help us understand that broader community input.
Yeah, and to Jake's point about connecting with folks you might not have before, Barbara mentioned earlier that there's a lot of really great literature, conference abstracts, et cetera, about many of the science topics Barbara talked about today. To Jake's point, now would be a great time to deep dive there and reach out. Love that focus on partnerships. Sarah, anything to add since I saw you come on video?
Yeah, no, this is one of the reasons we are having this discussion today, in order to give the community, a little bit of time to actually, refresh their memory about these things and go back and look through the literature and come to that workshop prepared and ready to discuss your ideas. So we're hoping that you've got the opportunity this summer to really put some brain power behind these things and show up ready. This is your opportunity to have input into this big endeavor that we are doing, and so I hope you all just take advantage of that.
Thank you. And the perfect timing to head into the next section of talks. I want to say thank Sarah and Jake for the headquarters perspectives, and especially want to thank Barbara and Jen, of course. I know this was a long time coming in getting this information out to you guys, and I know that they worked incredibly hard to do so. So really want to thank them. And now we will turn it over to the next session.